Hello again, North Tahoe physics students. In this brief video lesson, we're going to try to learn the basic of circuits so that we can work together in our class doing experiments and solving problems, but we do have to know a little bit about the elementary circuit design here. So our learning objectives for this quick show is going to be to identify the series of series and parallel circuits, describe the current through each resistive element in a circuit, and describe the potential difference across each resistive element in a circuit. A mouthful, but I think we'll be able to do it. It should be noted that we're going to deal with the simplest circuits that you can imagine, just two of them, series and parallel, but we can put these things in combination together and build the most sophisticated devices you could imagine. So this is the circuit board of a smartphone, and what we'll notice is even though it looks really complex and at first glance you look at it, you go, what is going on? It's really composed of just two simple types of circuits, which we will master in this class. And then if you wanted to go on to build something more complex, you'd take an electronics class or an electrical engineering course. Okay, so first, we're going to deal with just two. One of them is called a series circuit. So we've drawn a schematic of a series circuit over here. A series circuit is called a series because the resistive elements, now this needs a little bit of explaining, a resistive element could actually be something called a resistor, and its sole purpose is to resist the flow of electric current in the device. This is what a resistor looks like, and we'll see those in class. But a resistive element could also be a light bulb, it could be a motor, it could be like a radio frequency generator in a cell phone. Anything where electric current passes through it and is used to use some energy or dissipate heat could be a resistive element. So we're going to deal with simple resistors to begin with, these little guys. So series circuits are called that because the resistive elements of the resistors are in series. They're one right after another. This other thing here, this is the schematic for a potential difference or a voltage. For us to begin with, we can think of it simply as a battery. So here's a less complex design here. There's our battery, and we will say current will flow from positive through each one of those resistive elements back to the negative in that case. So they're in series because these bulbs or the resistors come one right after another. Parallel circuits are called parallel for obvious reasons, because the resistive elements in this type of a circuit are wired so when we draw the circuit parallel to one another. And again, here's our battery. So this one's a little bit different, right? Electric current could come through here and take this branch, or it could go through here and take that branch, or it could go through here and take that branch. So there's multiple branches in a parallel circuit where there's just one in a series circuit. So again, these light bulbs in this case are all lined up parallel to each other, whereas these light bulbs are all connected in series, one right after another. There's benefits and drawbacks to each type, and we'll explore those in class. So the key points we need to know as we're going to do our lab here shortly, our first lab with circuits, are what's unique about each one of them. So let's take a look at a series circuit. In a series circuit, we only have one path for electricity to flow through. If it gets blocked anywhere in this path, that path or the circuit then, as we would say, is open and no electric current can flow. There's only one path in that case. Sometimes it's helpful to think of a circuit sort of as a mountain or a hill like we've been dealing with electric potential. And in that case, we'd sort of stretch or pull the circuit apart. The plus we could think of as high ground up here, and the minus we could think of as low ground down here. So each resistive element, which remember could be a resistor or a motor or a light, drops some amount of height here. So this could be R1, drops one height. And then R2, which is this one, drops another height, R2. And then finally R3, which is this one, drops the next height. So what we notice is, if we think about the heights, the potential difference across each one of these, we call that delta V, and this is when we use the word voltage. The voltage is the potential difference across R1, the voltage across R2, and the voltage across R3 all of these would add up to the total voltage of the battery. So you can think of each one of these resistive elements uses some of the voltage of the battery, but added all together, we should come up with the voltage of the battery. There's only one path, so electricity would have to go through each one of these to complete the circuit. For a parallel circuit, there's multiple paths. So in this case, current can take this path back to the battery. Current can take this path back to the battery. Or current can take this path back to the battery. So if we do shut off one of these paths, say something breaks this path, there's still two other paths for current to flow through. We'll see that this has a lot of benefits, in especially designing electricity in your home. So there's multiple paths for current to flow through in this type of a diagram. If we think about in terms of that water analogy or falling down a mountain, this is what it would look like. The positive again would be high ground, and the negative would be low ground. And since we have different paths, this might be path R1. This might be path R2. And this might be path R3. So what do we notice here? Each one of these, the potential difference across each one is the same as that drop across the battery, delta V battery. So each one of these you can think of as using the full voltage of the battery. They drop the same height. They drop the same difference in potential. That also has some benefits. It also has some drawbacks, which we'll discuss. So as simple as those are, we can put these types of things together in a complex or a compound circuit and build everything that we imagine in our modern electric world. So in this case, we'll see we have one resistor, an 8-ohm resistor, and then in that element we have these two that are wired in parallel, but we would say this parallel is wired in series with these two. And I'm going through this real quick because we'll deal with these in more depth later. I just want to point out, though, we don't have to have purely one series or purely one parallel circuit. We can put these together to create a complex or a compound circuit. And we'll deal with these and work together in class. So go ahead and take the Google Form quiz and come ready to do a lab next class.